Good afternoon, ladies and gentlemen, and welcome back to another episode of Steel Connect webinar. I'm Rocky and your host today to talk more about how to select a more suitable building accessories and material during specification of external cladding. So the topic today is about selecting the right material for your building accessories during the specification of external cladding. So in our previous topic, we covered how to achieve longer lifespan external cladding through designing. Right? So that itself focused a lot on the overall design about the building geometry or even the roof pitch and so on. So today we would like to dive down into the small details. Right? So small details are more specifically in material selection for other components of the building, right? So all these small components, even though it's small, it could actually be very crucial for the overall building design. Okay, so even if let's say the building material or so-called the cladding material itself can last long, a failure could come through by using an incompatible material, or sometimes leakage could go through the weakest point of the cladding system, i.e. the fasteners. So today let's look into details about how to get all these small details or small material right in order for us to give you a more holistic or longer lasting external cladding. And before I dive into the topics, the principle or the working principle of most of these accessory selection in terms of material selection has to do with this thing called galvanic reaction. Okay, so the principle of galvanic reaction works in such a way where you have two different types of metal, and when you connect them electrically or physically, have this thing called galvanic reaction. And this is actually further promoted by the existence of moisture. So different moisture could promote the reaction, galvanic reaction, differently. Where if you have, for example, rainwater, then the rainwater itself will actually connect these two and cause galvanic reaction. And if let's say the rainwater itself is acid rain, then the reaction will be much faster. Same goes with if let's say the environment itself is near the sea or industrial, where normally you have something like sulfur dioxide and so on. So of course, galvanic reaction is actually based on this list of metals, which we call them galvanic series. And from here, of course, this is not an exhaustive list of metals. The more detailed one you can always search online. Just search galvanic series, and you have a list of metals that are available. So over here, there are actually two spectrums in this galvanic series. So one where we call them noble, or so-called cathodic, and the other spectrum of it is called active or anodic. So to simply put, the metals that are positioned in a more noble spectrum typically would not be preferred to react in the galvanic series. So if let's say it is paired up with another metal that is placed closer to the active spectrum, then the metal that is more active will be reacted preferably in the pairing of these two metals. So let me just put some examples. So typically for steel cladding, we have galvanic coating like zinc or aluminum zinc that protects the steel. So the working principle has to do with this galvanic series as well. As you can see from this galvanic series table, aluminum and also zinc is positioned relatively more active compared to steel. So in a way, aluminum and zinc is more active than steel. Hence, it will be reacted preferably compared to steel. On the other hand, if let's say you have metals like copper, brass, or even stainless steel, because they are positioned in a much more in a more noble side of the galvanic series compared to steel, they would in turn promote steel to be reacted much more faster. Because this is a relative law that we are talking about. And another thing that you can note is that from this galvanic series is in a layman's term, if let's say the position of it is further, then you expect the position in terms of in the galvanic series. If let's say it's further, then it means it will have a faster galvanic reaction if you pair them up together. For example, here I show you graphite compared to aluminium. So the reaction will be much more rapid compared to aluminium with steel. So that's how this galvanic series is read by a layman. Okay. So having understand that, let's just jump in to the a few aspects of the building material selection for building accessories. So the first one today will cover flashing and capping. So of course, as building as a whole, let's say it's cladded with steel, we know also that most of the subcomponents, such as flashing and cappings, can be placed in many parts of the building. So of course, you have a lot of terms like ridge capping, so on, which covers the apex and so on. And all these can actually be made of different metals. And traditionally, it is made of lead. Okay, so lead flashing nowadays is hardly seen, but in some part of the world, they are still using it. So lead flashing itself, if let's say it's paired up with steel, of course, if you recall the galvanic series, it is actually positioned in a much more noble part side. So that's why steel is rusted preferably. Of course, aside from lead, nowadays we see different types of coated steel to be used as flashing and capping. But of course, because it is a smaller component of the building, not a lot of people try to prioritize in terms of selection and so on. So in the specification stage, normally it is neglected. So what will happen is that it is as generic as possible, and end up you get a flashing and capping that do not perform as well as the steel cladding itself as a whole. So this is one example by itself. Okay. So the consequence of that is that the rust spreading from the rusted flashing or capping will actually spread on to the adjacent surface, so i.e. the steel cladding. And these actually do not just stop at staining. Okay, the stain itself might seem like it's on the surface, but let me just dive in deeper and look back at the galvanic reaction. Okay, so over here I shown an example of two different metals I mentioned earlier, aluminium and zinc paired with steel. So if you have more of this aluminium and zinc compared, on the surface of steel, of course, it will actually increase the protection level of these two metals towards steel. And if you have lesser metals of aluminium and zinc, that means decreased protection level. Okay, and the same thing can also be described as such, where if let's say you introduce external steel components that are not protected by another galvanic coating, so the same layer of aluminum and zinc will have to protect both the steel that it is originally protecting, as well as the externally introduced steel. So these, in a way, decrease the protection level, especially at the contact area. So let's just look in closer. For example, the flashing and cappings. If the rusted flashing and capping is in contact with the coated steel, what will happen is that over time, the contact area the galvanic coating, which is aluminum and zinc, will work harder to protect both sides of the steel. And over time, the one that is rusted, it seems like the stains will cover the aluminum and zinc, but even further down the road, then this is what you will see. Okay, it will actually lead to the galvanic coating being depleted much faster and leading to localized corrosion. So here are another examples of a corrosion due to direct contact with rusted component. So you can see both on the clips of this pipe on top with the clamp, okay, and the clamp with the steel cladding. The rust will start spreading from the already rusted steel to the one that is still having certain level of galvanic protection. So what is recommended is that you should actually always look for the same material that you use for your steel cladding to be used for your flashing or capping. So this has been done consistently in most of the projects nowadays, but we still see there are signs of rusted flashing and cappings in some other small warehouses. So with using the same material, what you have is a more consistent long-term performance overall. So it will have the same performance for your flashing and capping with your steel cladding. So moving on to the next topic, okay, so it's about fasteners. So let's just dive in to the topic. So most often we can see that fasteners, they are non-performing, looks like something like this, rusted crown, right? So this type of rusting actually, although it may seem benign, it might seem like it's not harmful, but over time it could have an adverse effect around the coated steel that it is in contact with. So over here what you see is what we call a ring corrosion effect, where just like the earlier flashing and capping, because the steel fasteners has rusted, it will actually prompt the coating that is in contact with on the steel cladding to start reacting faster. So it in a way accelerates the deterioration around the contact area. So in the market, there are actually different types of coated steel fasteners, and typically this is our typical recommendation. We will always recommend using at least a class 3 type of fasteners for your external cladding. And of course, a step further, if let's say the building or the cladding itself is placed at a marine area, or so-called generally a more corrosive area, then we would recommend something like class 4 fasteners, because in a way it can actually resist a longer lifespan. It can have a longer lifespan. But having state that class 3 or class 4 fasteners is not enough, because it is mostly vaguely understood, the term class 3 and class 4, right? And over here, what you can see is inconsistent fastener performance, even though all of them are classified as class 3 fastener. So what is class 3 fastener, right? So this is another type of unsuitable fastener that is most likely not going to be in the class 3 or class 4 fastener. Okay, so in order for you to answer this question, actually you can refer to this document called which is an Australian standard document. Okay, so the reference number is AS3566 Part 2. Right. So under this document itself, it describes very clearly what is the requirements for class 3 and class 4 fasteners, as well as what type of coating on steel that is classified as class 3 or class 4 fasteners. So of course, aside from class 3 and class 4, like the questionnaire I asked, class 1 or class 2 is a thing, right? Fasteners, but mostly it is used for internal building usage, meaning it should not be used for external application, such as external cladding. So the reason why is because it will actually rust much faster compared to class 3 and class 4. Okay. So class 3 and class 4, however, is recommended under the standard to be used as an external building usage. Okay. So another table extracted out from the standards is this table, where it actually lists down what are the possible coating and what are the possible thickness of this coating that is classified as class 3 or class 4. Of course, this table seems like very small and very hard to read. So I summarize it into these four types. So these four criteria are the one that they determine whether it's class 3 or class 4 fasteners. So it includes the coating type, which range from electroplated zinc all the way to mechanically plated zinc and zinc tin. Okay. And of course, aside from the method of applying the coating on steel fasteners, they also classify under different types of coating composition, from 98% zinc all the way to with zinc with a bit of tin content, and of course coating thickness and the type of passivation. And how actually do they recommend you to measure the coating thickness is actually through these two spots that is highlighted on the crown. So manufacturers normally is required to do all these tests in order for them to classify their own fasteners into such different classes. Okay, so typically for class 3 fasteners to be classified as class 3, okay, I only highlighted these three different types of tests. Okay, so the first one is it needs to be going through this accelerated test called salt spray test. And the minimum requirement under these documents is 1,000 hours salt spray test. And of course, they have actually listed out the criteria to pass under this document. And another way is what they call going through outdoor exposure test. So of course, if you ask me comparing accelerated test and outdoor exposure test, of course, the answer is outdoor exposure test will be much more realistic. And of course, they also listed out what is the minimum criteria in order for it to be classified as class 3. And of course, the third one is by determining the coating based on the table that I've shown you earlier. So these are the three types of more realistic way of testing the fasteners to be classified as class 3. And for class 4, there are two tests that I would like to highlight. So they would not recommend class 4 fasteners to be tested under accelerated test under this document. Okay, so instead, it has to go through external exposure test. And of course, another one is to measure the coating based on the coating composition, the coating thickness, whether it can be classified as class 4. Okay, so with these two, if let's say the fastener still failed, that means something is wrong with the fastener itself. If let's say it's classified as class 4. So on the longer term, if let's say the fasteners failed, okay, then if it starts rusting on the crown, it is still a chance for you to salvage it by actually replacing the fasteners until a point where if let's say the fasteners has started affecting the cladding around where it is contacting, then based on our experience, it's very hard to remove all these white stains, and it's not really a permanent way to solve it. So it's very hard for you to salvage the situation. Now, of course, some people might ask whether it would be okay just to paint over it. So we have also seen such cases happening. And based on our experience, this is what it will look like if let's say you paint over rusted fasteners, where the ring effect will still appear through the paint, because bear in mind the fasteners has already rusted. I bet you already know if let's say you painted over a rusted component, what will happen. So this is the effect. They can see a white ring that appears around it. Of course, another thing is that another questions that we get asked commonly is that how about stainless steel fasteners? And stainless steel, for your information, is classified as class 4 fastener, but it is not really a compatible material to be used in conjunction with steel, as you can see from the Galvanic Series table. Okay, so what you'll get also is a ring effect, and but in this case, the fastener itself will not show sign of rust, whereas it will actually induce steel to start rusting first. Okay, so this is another closer look in another experiment, and you can see the fasteners is still in good condition, but it has already affected the cladding that is painted around it, where you get to see some blisterings and so on. But there's actually a caveat. There's still a way to actually use stainless steel fastener on top of steel cladding. So, but it's not a really common solution. Okay, so if let's say you insist on using stainless steel fastener, then you might want to consider methods to isolate the contact point between stainless steel fasteners and the steel cladding. One example, as shown in this picture, you will see there's actually a sleeve around the fastener shank, as well as a flashing that is big enough to prevent such contact directly. And of course, by doing such isolation or a closer look when it's pierced through, you are able to prevent direct contact between the stainless steel and steel cladding. Of course, if let's say this fastener topic is too much for you, then you might want to choose another type of solution, another type of steel profile, right? Such as conceal fix or standing seam profiles. Okay, where these types of profile normally would not require external fastening. So with that, that is the second point on fasteners. And the third point is on lightning conductors. Okay, KL, Kuala Lumpur, is actually classified as the 5th highest number of lightning strikes in the world. Meaning, in a square kilometers, they found more lightning strikes in a year compared to most of the world. Okay, so so lightning conductors itself works as it tries to channel the lightning that is strike onto the building down to earth. So it actually forms part of the external lightning protection system, okay, or LPS. And of course, in order for you to fully understand or rather utilize this system, definitely I would recommend you to seek a reputable or any electrical engineer that is experienced in this field. Okay, so the design itself is quite complex, but in terms of lightning conductor material itself, the typical material to be used is always copper, right? Because first, I believe most of you will know, copper itself acts as a really good electrical conductor. Okay. So, however, if we look back at this Galvanic series, copper itself is more cathodic, also called more noble compared to steel or even aluminium and zinc. And because of this, copper will cause the steel cladding to corrode faster. Meaning, if let's say you install copper lightning arrestor resting on, say, for example, steel cladding or steel flashing and so on, then it will cause the coating, which typically made of zinc or zinc aluminium, to react faster. And in no time, you'll see sign like rusting around the copper tape. Okay. Another thing is that a misconception is that even if you lift it up, I know that lifting up the lightning conductor has something to do with not having it submerged under water during rainy days. Another thing is that it would actually not solve the issue of this contact causing steel to corrode. Okay. The science is that basically because of Galvanic series, it could actually cause steel to react faster. Okay, and to a certain extent, it could even perforate the whole steel, right? Leaving your steel cladding vulnerable. So imagine if you have a building where you have to remove your steel cladding because of lightning conductors, right? Then it will be actually not worth it, right? So especially for industrial buildings, where or even buildings positioned near the sea, this galvanic reaction will be much faster because of the environment. The basically the electrolytes, like the seawater or even the rainwater around those environment will promote this galvanic reaction to be faster. So what are solutions, right? So one of the solutions that I found online is this PVC coated copper tape. So far, based on my experience, I have not seen this kind of copper tape being used on site, but you'll be happy to explore this option. Okay. Of course, another option that is more common that I've seen on sites is by replacing the copper tapes with aluminum tape. Right? So based on a study shown, aluminum is actually 39% less conductive than copper. Okay, but okay, I'll address this question later. Okay, then you have a question based on this statement. Then why should I use aluminum? Okay, so first, aluminum itself is in the Galvanic series more active than steel, and as you can see, the positioning of aluminum and steel, they are not far apart. So that's why the reaction is very slow, so almost negligible. And in terms of addressing your question about since it's less conductive, then why should I use aluminum? So based on this EN standard, EN 62305 part 3, you can actually find a really holistic recommendation or guidelines on how to design a lightning protection system. And part of this information also covers what type of material is suitable to be used. And under this table set 6, you can see copper in different geometry or cross section is recommended to be used as lightning conductor, and aluminum alloy as well, where aluminum can be used, but given the cross section that is meeting the minimum requirements as shown in this table. So of course, one of the public standards documents that we have found this reference also is on our JKR documents, standard specification documents, where they specify for lightning conductors, you can actually use aluminum, especially it is installed on steel roofing. Okay. So come back to the conductivity. You can definitely address this concern, or so-called unknown, through referring to this table, as well as always consult your electrical engineer to see to have them sign off this cross-sectional area, whether it's suitable to channel the lightning strikes down to earth. Okay. So we have also seen some of the implementation of aluminum tape as lightning conductor successfully, such as this photo here, which actually has been there for more than 10 years. And as you can see here, it did not accelerate or cause any sign of corrosion on top of the steel. Okay. So on to the fourth point, which is on sealant. Of course, sealant is something that is really minor and most often unseen, right? Because it only applied in between the gaps and so on. So we know that sealant is typically used to seal any types of roof openings, such as the example shown here, or even to seal any lappings in between the steel cladding and translucent sheet, also to prevent some types of leakages. This can be contributed by the flexibility of sealant. But sometimes sealant itself can actually release oil substances upon breaking down. Some sealant, they might not release such watermarks, right? But some that are not performing might actually cause watermarks like this. So it will be hideous, for you to use that kind of sealant. Okay. Another thing is that sealant itself can be brittle over time. So you might not expect it to permanently seal the gaps, for 20 years, 30 years time. So you need to pay attention to what types of sealant that you are using, as well as whether it is waterproof enough, weatherproof enough. Okay, so typically for external cladding, you need the sealant to be weatherproof. I think this is, goes without saying. But another thing that is not commonly known is that sealant, they can be containing different substances. And the one that contains acids should not be used for in conjunction with metals or steel cladding specifically. And if you can see from this top left corner, acidic cured silicon is actually acids, contain acids. Okay, so acidic is actually acetic acid or acetosol, which another term for acid. And this type of sealant will actually cause steel to rust faster because of it contains acid. Okay, so on the contrary, you should look for sealant that first weatherproof, and second should be neutral cure. Okay, meaning it does not contain any types of sealant. And for layman's, if let's say you want to know upfront whether the sealant is neutral cure or acid cure, one of the common ways for laymen to actually identify on site is you get a strong smell of pungent smell or ammonia smell if let's say the sealant itself contains acid. So that is what I learned from some of the old folks that is on site. So another thing is that for sealant, you should always pay attention to the method of application. And of course, this example shown here is one of the nicer one. And if let's say the application is not done right on site, sometimes before it's cured properly, they might have workers that touch the cladding and then staining it around the cladding, and eventually causing staining all over the cladding. So this example that's showing on the screen, it was caused, the staining was actually caused by workers stepping on the uncured sealant and stepping around the roof. Okay, and eventually these stains will be shown much more easily, and then it is very hard, I would say almost impossible for you to remove it. So do pay attention to the again type of sealant as well as how you actually apply it on site. And the last part is on other building components. Of course, over the years we know that big buildings or warehouses, they have increasingly installed, say, solar panels or some types of components on the steel cladding or roofing to add value to their building. So all these systems, right? Actually, it comes with different components that can be made out of different metals. So I'll just briefly run through the last one, which actually has elements of the previous 3 or 4 points. Okay, so the first one is most commonly known as solar panels or solar photovoltaic panels. And these type of systems normally, first thing that you need to know is that they actually come in systems, right, an array, and they are connected by cables, which the cables itself needs to be in tidy manner. So normally they'll have a cable tray that's made out of galvanized steel. So again, referring back to the first point of flashing and capping. So if this galvanized steel itself, started rusting, I believe there's a clause, some of the provider will actually tell you that they will actually replace it. So again, if let's say the cable tray itself is rusted, then you have a potential risk of having the rust staining onto the cladding. And if let's say in the longer term goes without fixing, then it will actually affect the performance of your steel cladding. Right. And another thing to know is that most often people ask me, how about the clamp, right? What type of metal to be used for the clamps? So as long as the metals, as I highlighted in the few points, as long as it is aluminium, paired with steel, it should not have any issue, because aluminium would not induce any types of galvanic a reaction that will be harmful to steel. Okay, and this is one example that is commonly seen where they actually use a concealed fixed profile and aluminum clamps. And if let's say the metal is made out of stainless steel, which is normally not common, but I've heard before, if the clamps is made out of stainless steel, then you might want to consider an isolation layer in between the steel cladding and the stainless steel clamps. Okay, so it's okay for stainless steel bolts or components to be right above the steel cladding, but not in direct contact. So that is the most important point. So another systems or components that could be installed onto steel cladding is solar water heater. And this is more commonly seen on, say, houses, right, where each individual houses will be installed with solar water heater, especially by large-scale developers. So one thing to be noted is that there will be pipings that are could be made of, say, copper or stainless steels, right? So if let's say it's made of copper, the ideal case is you should insulate the copper pipes that is externally exposed to the rain. So these are examples of stainless steel and also copper pipes, right? So again, the preference for steel cladding is that you should use a stainless steel pipe for that one exposed. Okay. And if let's say you use copper pipe that's exposed to external, the water runoff itself could eventually cause so-called accelerated reaction I mentioned earlier. And this is an example where typically for water heater, copper pipe runs in between the panels. So this rusted arrow, seems like an arrow, is actually caused because water leak through the copper pipe, right? So the water carrying all these copper ions actually started reacting with the steel cladding, causing it to rust faster. Okay, so I mentioned earlier, no direct contact of stainless steel will be the best solution for the one externally. Okay. So to summarize today's topic, the first point is flashing and capping. We encourage you to use the same material as your cladding, okay, so to give you a much more consistent result. And the second one is on fasteners, where we recommend at least a class 3 fasteners, and you should insist on class 3 for external cladding application, so that that is not the weakest point for your cladding. Right. And third point is on lightning arrestors or conductors, where you should either use, you can consider PVC coated copper or even aluminum to prevent any types of bimetallic reaction or galvanic reaction. And fourth, sealant. Ensure that it is actually weatherproof and also neutral cure sealant, so that it will not react or so-called cause corrosion on to the steel components. And last, ensuring that all the other materials that made up the building components like solar water heater and solar panels are compatible enough with the steel cladding, so that you can actually provide a much more longer term performance. If you have any questions, you can actually ask now in the Q&A box, and we will get straight to the questions that is being asked earlier. So the first question is, can silicone or rubber cap on fasteners help to prevent rust affecting the external cladding? Okay, so I think you are referring to the first point where we are talking about fasteners. So if let's say you cover it with a silicone or sealant or rubber cap, actually it's two different scenarios. With silicone, normally you would cover the whole crown or the entire fasteners. So it should not have any issue, right, of leaking. Bear in mind the sealant point, which is on the fourth point of this topic. So it has to be a neutral cure, as well as it has to be weatherproof. Otherwise, it will defeat the purpose of sealing the fasteners that you are trying to prevent leaking from. We have seen it done, but if let's say it's used for a nice building, then it'll be kind of ugly. So it's pros and cons over there, whether you are looking at functional over beauty. So of course, on the second point, on the second material, which is rubber cap, we have seen it also. Rubber cap on tops of fastener. The intention was to actually prevent the crown from rusting. But throughout some of the observations that we have seen, the rubber cap, also called the plastic cap, actually did not help a lot in terms of preventing rust. Because if let's say you have seen the caps, right, it is not really 100% sealed, and water could actually seep through the caps to actually be contained within the crown and start reacting with the fasteners. And we have seen the same ring effect on fasteners that has cap on it. And it is not really a permanent solution in my view. And yeah, so the more effective one would be on the silicone sealant. Okay. So the second question is, if I want to cut some part of cladding to put steel tie, will it be an effect or avoid the warranty? I think, okay, Sarah, I think you need to be more specific. What do you mean by cut some part of the cladding to put steel tie? Okay, so Paul, your question is, what do you recommend to cut cladding? Okay, so of course, we plan to cover this topic in more detail in the next Steel Connect webinar, where we'll talk about on-site detailing and how to actually treat the material. Of course, I can give you a much more straightforward answer. Okay, so Paul, thanks for also raising some examples. Is it okay to use grinder or heat issue? Is there any heat issue? Yes, the concern that we have normally is that for cutting the cladding on site, of course, there will be a lot of tools, handheld tools that you can use. And typically, the more common tool is called grinder, where the cutting method is abrasive. So typically, you can see when you use the grinder on any types of steel components or metal, then it will actually generate sparks. And this is what we call as abrasive cutting, where it actually will grind off the steel sheet, right? And this is not really a preferred way of cutting because it will actually remove the coating, but not necessarily sometimes remove the steel entirely or rather cleanly. So it will actually create what we call steel burr. And this kind of steel burr itself is actually quite ugly first, and second, it would actually be the entry point or the weakest point for rust to start. And once steel burr start rusting, and then it will start spreading inward. And based on our experience, the result is not the best, and over time, rusting could start happening from there. And the effect of this steel burr will be very similar to the flashing and capping sign of rusting that I mentioned earlier or described earlier, where you have extended amount of steel for the coating adjacent to it to protect. So the reaction of this coating, like example aluminium zinc, would be faster, and hence your cut edge will be in a shorter lifespan. Okay, so Johan, so you mentioned would like to know if she cut through the cladding to install a chimney or vent, if it will void the warranty. So okay, so I finally get your message, Sarah. So I think if let's say you're talking about cutting through the cladding to make way for chimney or vent, would it void the warranty? So my answer is depends on what Paul mentioned earlier, what kind of cutting tools that you need. And again, sorry Paul, the type of cutting tools, or rather I answer both questions at the same time. Okay, so for you to cut through the openings of cladding, you need to use a proper tool, right? Actually, the most ideal one is designed to length, and also so that your manufacturer can cut it in the factory and send it on site. So you can actually eliminate this issue. But if let's say you really need to cut on site, then we actually have studied some tools such as cold cutting tool, meaning instead of abrasive cutting, it actually will have a much more cleaner cut and then more specific to cutting steel also. And this kind of cold cutting tool, it will provide a cleaner cut. But another limitation is that sometimes it will not be big enough to cut the whole cladding. So you might want to consider another tool, which is what we call thin snipper or shear cutter. And that is what traditional people use to cut on site, and it's actually much more preferred compared to say other type of power tool. Okay. Another one that is lesser known is called Nibbler. So you can search online, called Nibbler, Nibbler, right? So this kind of tool actually chips away the steel like bit by bit, and then it can also provide a cleaner cut. And you can also do some curve cutting also. Okay, so Jack, so most of the engineers still insist to use copper rather than aluminum lightning arrestor. What will happen to blue scope warranty if proceed using copper arrestor? Okay, so Jack, I think you highlight something that most consultants will always be concerned of, and actually we have some property management companies who are also concerned about this as well. So if let's say they insist on using a copper arrestor or conductor, then as you can see from the Galvanic series, it actually scientifically has proven that copper itself on the long term will definitely cause steel to react faster, and it does not actually provide a long-term solution for your steel cladding material. That's why for us, we would not encourage you to use copper conductor or arrestor. And in the case where it happened, right, we would not recommend to offer any warranty. And because it does not get aligned with our value of longer term material, long lifespan cladding system. And yeah, I hope that answers your question. And Tajuddin, so would you allow your cladding product to be used as lightning conductor? I've been made to understand that this may be done if the base metal is greater than 0.48 mm. Okay, so the thing about natural lightning, using a steel cladding as lightning conductor is you need to look at what type of base metal it has, right? So based on the standards that I quoted earlier, which is EN 62305 part 3, they also quoted this component, this thing that you are asking, where we are using the steel cladding as what I call natural air termination, meaning if you in a case you do not want to use a lightning conductor, then you can actually remove the lightning conductor, but you need to actually consider the thickness of your steel or so-called base material or substrate, and for you to consider the minimum thickness itself. Of course, the minimum based on this standard actually specifies 0.5 mm thickness for the whole galvanized steel, meaning your base steel, including the galvanic coating, should be at least 0.5 mm thick, and typically we refer to that as TCT. And if let's say you can achieve at least 0.5 mm TCT, then it is eligible to be considered as a natural air termination. One thing to note, under the standards, they also specify the thickness of 0.5 mm is not going to prevent types of spark or even explosion of the sparking point where of the flash point where the lightning strike, because this thickness itself is not sufficient to prevent any types of damage if let's say there's any lightning strike. the thickness, if I recall correctly, don't take this blindly, right? You have to refer to the standards. If I recall correctly, it has to be at least 4 mm thick for the steel to prevent spark or so for bursting upon flashing. Right, that is the thickness that you need for cladding to act as a natural air termination without damage. Right, but again, I would encourage you to always consult your electrical engineer to have a sign off, because at the end of the day, that itself would be very specific to your building, and because each building position as well as location would be influenced by how likely it is to get a lightning strike also. Okay. What's the remedy to address sealant stain on cladding? Okay, so the remedy action, actually currently we do not have any types of conclusive remedy action. We are still exploring, because so far we have not found a solution to remove the sealant stain nicely without damaging the coating. And of course, it is sort of something that we do not really encounter more enough, or rather, have any existing solution for that. So, yeah, no, we so far do not have any proper remedy action. So, how to check the fastener use is class 3 on site. Not all fasteners has class 3 label. So yes, you're right. So not all fasteners has a class 3 label. So when you are specifying the fasteners, if let's say you want to be more specific to the make, or rather the manufacturer, you can always specify their fasteners, because again, you have to vet through who are claiming that they have class 3 fasteners and has proven themselves based on cert or based on test results, the list of testing that I mentioned earlier, that their fasteners can be considered class 3. Typically, if let's say they do, then they have a way to identify the fasteners, whether it's made by them or not. And yeah, I bet that's the only way based on what we have observed. Those that normally on the crown, they will have certain specific labeling on top, so you can always refer to them. So another question, if I find that there are burr edges on my roof sheets or flashing during a regular maintenance schedule, say 2 years after installation, would you advise that a metal file or burr tool to be used to remove this and save the material? Oh, yeah, so sometimes I get it, some projects that might have, say, inspection after every year, after the building is completed. So sometimes you might not notice these kind of issues of burr edges. So maybe one of the tools that you can use is also deburring tool, or you can actually cut the cladding shorter using a proper tool, so that you can actually remove the burr properly. So still metal file is, we have not seen a very conclusive solution using metal file, but you are free to try to explore this if let's say you have such an issue on your project or building. So okay, so we have one more. Okay, so this will be our last question. So for those who did not get to ask your question, the next, hold on, in case you did not get to ask your question before I answer this last question, feel free to hit us on all these different platforms. Okay, the last question is, what's your view regarding using stainless steel fasteners on steel cladding? We were informed by Singapore client that it's mandatory for local authority in Singapore. Yeah, so stainless steel fastener as we know it in Singapore is compulsory to be used as external cladding. So our recommendation has always been previously that if let's say stainless steel to be used on the steel cladding, then it will have an effect of galvanic reaction. But we also, upon the years, have also found that certain stainless steel cladding position in, say, the town, right, very far away from, say, industrial area or so-called marine environment. So those kind of stainless steel fasteners seem to have very minimal effect on steel cladding. As I mentioned earlier, there are a few things that would affect the galvanic reaction speed, right? So one is the positioning of it in the galvanic series. If let's say it's closed off, then the reaction will be slower. And based on the Galvanic series, if you recall, the positioning of certain stainless steel with the steel is actually quite close, so the reaction will be minimal. But of course, if it's located at marine or industrial environment, that definitely is a no-no because the reaction will be much faster, and we do not want to endorse that. And of course, the best solution to be more permanent is to have some sort of isolation component that could actually prevent direct contact in between stainless steel fasteners and the steel cladding. And I hope that answered your question. With that, I would like to conclude today's Steel Connect webinar. And again, thanks for joining us for another session, and we would hope to see you or hear back from you in the next session. Thank you.